It is quite obvious that when we create vectors or matrices in Matlab, we don't do it just for fun, but rather because we need to use them in some calculations. So this video will get through the basics of operating on matrices in Matlab. And this is where what I mentioned in the beginning comes in. So it is really important that you have the basic idea of matrix operations. So you know what kind of matrices can be added, can be subtracted and multiplied with each other. And the rules are relatively simple. So operations like addition and subtraction can be done on matrices which are of the same size. So now if I have matrix A, which is, for instance, 1, 2, 3, and 4, so I can only add another matrix B to it, or whatever the other one would be called, only if it has the same size. So if this one is 2 by 2, then the B matrix will have to be 2 by 2. And it's the same case when we deduct a matrix from the other one. And then what happens is that we would just add respective elements. So first element of this matrix, so the one in place 1, 1, would be added to the one in the same location, so place 1, 1 in matrix B. Then the one in place 2, 1 added to the one in place 2, 1 in B matrix, and so on. However, multiplication is a bit more tricky, because in matrix algebra, multiplication needs very specific arrangements. I will use the previous slide here. So if we have matrix A, and let's say 1, 2, 3, 4, 5, 6, then this one is 3 by 2, and it can only be multiplied with a matrix which has same number of rows as this one has columns. So the rule is that A times, which has size, let's say m times n, is only possible in algebraic way when we multiply it with matrix B, which has same number of rows as this one has columns, and then it can have any number of columns. So these two need to match in order for us to be able to actually do the amount multiplication, and the resulting matrix will have size m times k. So for instance, if I would have now here 1, 2, 3, 4, 5, and 6, so it has 2 rows and 3 columns, or even let's make 5, 6, 7, 8, let's make 4 of those. Then this is okay. And how the multiplication happens is that our C matrix now will be 3 by 4, and it is done so that for the element in here, in place 1, 1, we take first column of our B matrix and we multiply it with first row by adding. So it's 1 times 1 plus 4 times 2. And this becomes the first element of our C matrix. Then the second element, which is below here, it means that we will take the first column in here, but we will multiply it with second row in here. So it will be 1 times 2 plus 2 times 5. And then first column with third row, 1 times 3 plus 2 times 6. And that's only the first column of our C matrix. So then I would go on using the second column and again multiply it with each row of A, one by one, and write the results here. Then I will take third column with each row, and I would get third column of my matrix C, and then the fourth one. So that's how the resulting matrix C is 3 by 4. So it's this 3 and this 4. So this is the algebraic multiplication. But luckily for you, usually, not always, you may end up having to know how to do that algebraic way. For instance, when in some further applications you do linear regression or some other modeling. But if you do basic operations, normally you don't need to know that algebraic one, or you don't need to use it. It's good if you know it, but you don't need to use it. However, you should use so-called element by element operations. So now that will mean that when I have A being maybe 1 and 2, and I have B which is maybe 3 and 4, when I want to multiply A with B with the so-called element by element operation, that means that I only want to multiply 1 with 3 and 2 with 4 and get this kind of matrix which is same size as the other two. So in that case, that operation is only allowed if these two matrices A and B are the same. So the same as with addition and subtraction. Also, if you have some, maybe you have a vector of elements, 1, 2, 3, 4. Well, it can be any, let's say, elements from 1 to 100. And you would like to quickly calculate square of each of those without having to do it one by one or maybe using a loop. All you can do, or the easiest way you can do, is you raise it to power 2 like that. So now you tell Matlab, take my vector x, use every element from it one by one, and one by one square them. So the resulting vector would be, again, having 100 elements, but each of them would be squared with respect to what it was in the initial vector. If you try to do x square without the dot, you should get an error, because it would mean trying to multiply vector like this by vector like this, which is not allowed in Matlab. So we would get the error of matrix dimensions. Let's try a quick example. Uh, 1 and 2, and then I want to do x square. Now I should get an error, and the error actually says error using power, incorrect dimensions for raising a matrix to a power, check that the matrix is square and that the power is a scalar. And to perform element-wise matrix powers, use dot power. So element-wise means element by element. So if I really want element-wise, then now my result will be 1 and 4, vector of 1 and 4. All right. So here are a couple of other examples. So for instance, we have matrix A, which is 2 by 3. I have 2 rows, first row, second row, and this one is 3 by 2, because there are 3 rows which are defined separately. So when I try to create matrix C, which is a sum of those two, of course I am not allowed to do it, because the sizes are different. They are similar, but they are not exactly the same. The dimensions are flipped. So this would only be possible if we actually made A maybe plus B transposed, because transposition, what it does is that when you have matrix arranged like this, it kind of flips its dimension So it swaps. If something was 2 by 3, it will become 3 by 2, and so on. So whatever was in specific row will be written, sorry, whatever was in a specific column will be written in a specific row. Okay, and then second example, we have two matrices which are actually same size, so 3 by 2, both. But we are trying to multiply them with the algebraic multiplication, which is not allowed because number of columns in the first one is not the same as number of rows in the second one. This is not matching, so it is not possible to be done. And the error says very clearly, if you want element-wise multiplication, please use dot. So I should have written A dot multiplication B. And one more operation to which it applies is division. So once again, if you have some matrix and you would like to divide its elements by something, you have to use the dots. And also, if it's a matrix divided by matrix element-wise, then the size of the matrices has to match. There are now some exceptions. In older versions of Matlab, for instance, if I had a matrix 1, 2, 3, 4, maybe let's go into Matlab directly. Let's see. 1, 2, 3, let's say 4, 5, and 6. So this matrix is 2 by 3. And I will have another one which is, it has something like this. One column that you divide element-wise. So let's say x by y, you would get an error. At least like 3 years ago, if I remember correctly, it was still working this way. Now, MathWorks is trying to go user-friendly. So now, how it would understand this operation is that you're actually trying, since the number of rows is matching in your Y matrix and X matrix, it will understand that you actually want to divide every column of X by that, sorry, I didn't execute Y, that you want to divide every column of X by Y. So now what happened is that it did it element-wise. Let's have a look. Y was 1, 2. 1, 2. So now it divided 1 by 1, 4 by 2. And we have the result 1, 2. Then 2 by 1, 5 by 2. So we have 2 and 2.5. And then 3 by 1, 6 by 2. So the result is 3 and 3. So that's how it understands it these days. But if you tried the same few years ago on some older version of Matlab, you would get an error. So it does make things easier in some specific tasks. But on the other hand, for people who have been using Matlab for a long time, sometimes it's a bit confusing, and it takes time to learn it fresh. But since you're learning it right now, you may actually adapt to it easily and make use of it in the future. Okay, so let's go further. Of course, Matlab has lots of built-in functions, especially for mathematical operations, and not only. And depending on the function or on its role, and depending on whether you apply it on a scalar, a vector, or a matrix, you may get varying result size or what it looks like. So, for instance, function abs, which is used to calculate absolute value, will want to work on every element individually. So, if x is a number or a scalar, in other words, then of course absolute value of x is also a number. If x is a vector, then the resulting absolute value of that vector will also be a vector, just with respective results. So for instance, if my initial vector is 1, minus 2, minus 6, so absolute value of that will be 1, 2, and 6. It's quite straightforward. And the same for a matrix. If X is a matrix, then A of X, so the absolute value of that matrix, is a respective matrix filled with absolute values of individual elements of our original X matrix. However, for instance, there are some functions which are intended to make calculation on a bunch of numbers and give you one number as a result. So, for instance, summation is such an example. So, if you say sum of a single number, what will happen is that, of course, that's just that one number, because it is kind of itself. It's not even added with anything else. If you have a vector, whether it's a column or row vector, it doesn't matter. Let's say 1, 2, 3. Then Matlab understands that you want to add up those elements. So really, regardless of whether it's oriented horizontally or vertically, as long as it's just a vector and not a higher dimensional matrix, it will actually add up those elements. So the result will be 6 here. So if X is a vector, either row or column, then Sx is a number, so same as for an individual number. However, if X is a matrix, let's say 1, 2, 3, and 4, then Matlab will not add everything together. So the result is not 10. Matlab will add them up by column. So it will add up, squash all the rows together so that you will get a resulting vector, and it will be 4 and 6. So it's 3 plus 1, 2 plus 4. Now remarks. If you would like to do this summation the other way, you can do it by giving an extra argument. So you will have to say sum. Then you give your matrix. Let's say that this is matrix A. You say matrix A, but then you say that you want to squeeze the second dimension. So you want to kind of reduce the second dimension. Second dimension is column. So that means that it will now go through every row and add up the values of all the columns. So if I did this, my result would actually be, it would be 1 plus 2 and 3 plus 4, and arranged also in that way. So it's 3 and 7, a column vector, because it kind of reduces all the columns into one and keeps the number of rows. If there is a case where you actually want to add up all the elements, so what you have to do is to do the summation twice. So you make a sum of your matrix, because the first sum will produce this, and the second sum will now work on this one. So this will actually give you result 10.